Galaxies emit a lot of their energy as starlight, which we can see in the optical. And so here you see the black body spectrum, the amount of energy that comes out as a function of wavelength, peaking at around the optical part of the spectrum for a redshift of 0 object. So redshift 0 means it's local in our own universe. Now, as you're looking out in space, you begin to look back in time. Astronomers measure that in terms of redshift. And if you march out in time, farther back in space, the wavelengths of the light get stretched by the expanding fabric of space-time. Think of if you were shaking a rope with a friend of yours and you started backing up with it, you would be flattening out, increasing the wavelength. The same thing is happening as light travels across space-time to us. It's getting shifted to the red. And so if you move to a redshift of 3, you can see where that peak used to be in the optical. It's now in the infrared part of the spectrum. And if you go out to a redshift of 10, which is about where Hubble can see to, maybe a little farther than that now, you're starting to get into the mid-infrared. So to find these early galaxies, you would like to optimize to be an infrared telescope. That's where the light is. The other thing that redshift does is it decreases the surface brightness. It makes the objects harder to see. They've become fainter. So you need an infrared optimized, bigger telescope. And that's really the genesis for the James Webb Space Telescope. It was this phenomenon that Hubble looked for, couldn't quite make it, and it told astronomers, the astronomical community, what the next step needed to be. Now, one of the benefits you get of having an infrared telescope that you've built for this is that it's also going to be very capable of looking at objects at cooler temperatures. Again, if you look at starlight, stars emitting a lot of their radiation in this visible part of the spectrum, that's a characteristic temperature, several thousand degrees Kelvin. If you have an infrared optimized telescope, it's going to be more sensitive to cooler objects, and so you'll see the universe in a slightly different way. You'll be looking at different physics, and we'll be most sensitive to objects in the hundreds of Kelvin range locally. This is more for experiments we would do within our own galaxy.